This video is going to discuss running a logistic regression model that has multiple numeric variables in addition to a dummy variable. So I've downloaded the file Logistic2 and then saved a copy as Logistic2 bank loans because in this particular example, I'm going to use the file called bank loans, which is an Excel file, and pull that in as the data set. All right, so here are the bank loans data set. And the key is that the target variable here is personal loan, which is a decision about whether or not a person takes out a personal loan. And we've got many other variables here. And so I'm going to insert a cell above and go ahead and just do dataset.info to see the different fields that are in the data. Now, we've got several things that are obviously numeric variables like CC average, because that's a decimal variable float. But some of these other things, such as income, for instance, are also numeric. They do show up here as integer because there's no decimal values, but we would treat that as a numeric variable. There's some other things here that are dummy variables. Okay, so what we'll do now is let's just see which values are in certain variables here. And so what we can do is go to data set and look at a variable like, say, income. And look at the value counts. This is a good way to see what's in a variable. And so we see here, even though income was an integer variable, it takes on lots of different values, from 8 all the way up to 224. Now, if we look at something like credit card, and do the value counts, we see it is truly a dummy variable with zeros if a person doesn't have a credit card and ones if a person does have a credit card. And so we'll treat this as a dummy variable, but even though income is an integer, it would be treated as a numeric variable. Okay, so now what we're going to do is import a model and create a logistic regression with two numeric variables. And the thing we're going to have to do in that situation is scale the variables, because these are on really different scales. If we look at something like experience, that would be in years. Income potentially is in thousands of dollars, but they're not measured on the same scale. Okay, so we can scale these, and that's what we'll have to do to fit the logistic regression model. So let's go ahead and specify the x variables. And one way to do this is to pick out the columns here and put the columns in a list in brackets. So we'll start out by fitting age, income, and then credit card as a dummy variable. And so age is column 0, income is 2, and credit card is 11. But for right now, what we're going to do is go ahead and just specify the numeric variables. Keeping in mind that we are going to include a dummy variable eventually. And then the personal loan variable is the target, and that's the last variable, which we can specify with -1. Okay, so now what we need to do is we have two variables here, age and income, but those are on different scales. One is in years, one is in dollars. And so we need to scale those onto a common scale. And the command here does that. It's going to take the X range and then transform those onto a common scale. And what that now looks like, if we look at X, is they're on a common scale where some values are negative and some values are positive. And generally what that represents is whether something is above or below the mean. All right, now what we would do is add our dummy variable. So for our dummy variable, we're going to use credit card, but there's others, online, CD account, or other possible dummy variables. And so we're going to do new column. And then 11 is the new dummy variable. And it wouldn't have to go in a list here, but this would allow me to, if we wanted to go back and test multiple dummy variables, put those all in this list. Now we need to append this new column to the original X. And so this is done this way. This takes the old X, adds the new column. Axis equals 1 means add this as a column, and then it creates a new X. So now if we look at this, we have our two scaled numeric variables, and then we have our dummy variable. And now we can go on and do the test train split like we typically do to fit a logistic regression model. And if we want, we could look at X train and see that we have just a subset randomly selected. And if we look at Y train, we should have the ones and zeros. These are for the personal loan. Okay, so now we would go ahead and run our logistic regression model. We're going to leave out this part for now on predicting a new result. Okay, so we can run that, and then we have our confusion matrix. So we had about 1,250 values in this test set in this confusion matrix. And so we can plot that and see a graphical view of the confusion matrix. So in this case, our accuracy is 92.4%. It's also nice to measure the false positive and false negative rate. And so if we want to do that, let's measure the false negative. Here, the false negative rate, if we look at CM, remember CM was the confusion matrix up here. If we look at the false negatives are these values here. These are predicted to be negative. In other words, person did not take out a personal loan, but in which case they actually did. So that would be the one row and the 0 column. Divided by the length of the test set. So that should be these 67 values. These are the false negatives, predicted as negative. And then if we want the false positive, these would be in the first row, second column, 0 row, second column. And so that is about 2.24%. All right, in this case, we won't be able to run this code on visualizing the test set results because we have more than two variables. So that shows how to run a logistic regression model with multiple continuous variables and a dummy variable, but we could also put more than one dummy variable here when we specify the new columns.